So today we're looking at superconductivity, and particularly something that happens when you have a superconducting material and some strong magnets, and that's levitation. Levitation you might think of in terms of magic tricks, but as I say, this is just a property of materials like this one here, which is a very special kind of metal alloy or ceramic. And what happens is when you cool this down to about minus 200 degrees Celsius, you get a process called superconductivity, and that means that rather than the electrons that flow through it bouncing around, they can travel straight through. You get zero resistance. And that's very exciting for things like energy transmission, transmitting electricity through wires, because if we could have a superconductor at room temperature, we could do that without losing any energy whatsoever. They also have some other interesting effects. So what I have in here are two little pucks, just like this one here. I'm going to cool them down using liquid nitrogen, which I will of course pour using gloves just to be on the safe side. And if I pour that through here, what we're going to then be doing is cooling these pucks down to about minus 196 Celsius. And this is liquid nitrogen, so nitrogen, the gas, cooled down to, as I say, minus about 200, so it forms a liquid. Now if I check with that, I'll move that away. Hopefully, there we go. What you can see here is a levitating box. And if I push that round, you can see it moves very freely. Now this levitates because of two things. Firstly, the Meissner effect, which is what happens with superconductors. You cool them down, they then reject the magnetic field. So the magnetic field would usually pass through them. In this case, however, because it's a superconductor, that magnetic field is forced around it. So it then rejects or repels any magnet that comes close to it. So that's what allows it, produces the force that levitates it. Now you might notice as well that this isn't sort of carefully balanced. I can whack it and it'll wobble. I can even sort of push it down and it'll bounce back to where it was. And that's because of something called flux pinning. If you have a magnet that's strong enough or has a strong enough magnetic field, then it penetrates the superconductor ever so slightly and you get small magnetic fields through it. And that flux pinning is what locks it in place and means that this can go around the corner and forms quite a stable little train. And as one example of what it could be used for is producing very efficient trains. So we see here we've got a very old-fashioned steam train, but provided with a quantum levitating track or a superconducting levitating track, it has very little friction. You compare the friction of this system to a friction with wheels and bearings and all the other gubbins that modern trains have. This would give us a much more efficient way of travelling around the country.